Good evening, children. We'll go with the new chapter, coordinate geometry. Coordinate geometry is not the new concept. You have studied in 9th also. I thought of doing all the chapters revisions again. Those are which chapters I had completed. And because of your yesterday's carelessness, I decided not to do any revision because you all know everything. So instead of wasting my time to do the revision again and again, better I can go ahead with these chapters which I left. 5 more chapters, 5 chapters I think. In this coordinate geometry, they have deleted the finding of area of the triangle formula, area of the triangle, and calculating the area of the quadrilateral, showing the points are collinear. Remaining all concepts are there. In 9th standard, you have studied about the coordinate geometry, that is, keeping two number lines perpendicular to each other, you will get a plane called Cartesian plane. So in that Cartesian plane, we used to plot the points on the Cartesian plane so far. We used to identify where exactly the points lie. Like that, we used to plot the graph of the equation on the graph that is on the Cartesian plane also. Now, in this chapter, we are going to find out distance between any 2 points on the Cartesian plane. Suppose if you have 2 points P and Q, we have to find out where exactly it lie and what is the distance between the 2 points which are having the order pair x1, y1 and q, x2, y2. So we name this as a distance formula. Distance formula is the formula used to calculate distance between the 2 planes on a Cartesian plane. That is PQ equals root of x2 minus x1 whole square plus y2 minus y1 whole square, where x1, y1, x2, y2, they are the order pairs of the points P and Q on a Cartesian plane. Is it clear? So the derivation of this in the textbook, but it's not for your exam point. There is a reason I just took it as direct distance formula. We call this as distance formula. So we can also write this distance formula PQ as root of x1 minus x2 whole square y1 minus y2 whole square, because square of a negative term is also positive. Either we can take x2 minus x1 or x1 minus x2, the final answer will be same. So this is about the distance formula. Now the next question, suppose one of the point we consider is at the origin, and we know that the order pair of the origin is 0, 0, that we already learnt in 9th standard. The 2 axes where exactly it intersects gives the point position called origin. So that origin has the order pair 0, 0. Suppose one of the point is at the origin. To find the distance from P to Q, this PQ, then we use the same distance formula. PQ equals root of x square plus y square. Because we have x1, y1, 0, the improved version of this distance formula, that is root of x square plus y square. So please note down the formula. First formula in this chapter, coordinate geometry. where we can find out the distance between any 2 points on a Cartesian plane. And this formula is applicable when 2 points which are equidistant from the x-axis point, or if we know the distance, we can find out any one point in the order pair, and we can find out the point on y-axis, point on x-axis. Let us discuss about the point on x-axis and y-axis. This is about the distance formula. Next, in 9th standard itself, you have studied in linear equation what is the point on x-axis and point on y-axis. XO, X dash, YO, Y dash. The point on x-axis is we consider as x comma 0. The point on y-axis we call this point as, suppose if I take Q, it will be 0 comma y. You may have the negative 0 comma y also, negative x comma 0, which is in the left side of the x-axis, down part of the y-axis. And in the question, if they mention the point P and Q are equidistant from the point on x-axis, how to locate the distance, how to find out the unknown, how to get the points on the x-axis or y-axis. This is one of the application of the distance formula, that is root of x2 minus x1 whole square plus y2 minus y1 whole square. The second application, the first application is to find out the distance between the points. Second application is to find out the point on the x-axis or point on the y-axis. The third application is to find out whether the order pairs or the vertices of a square, how to get they are the points on the vertices of a square is the question. They will give the points here 2 comma 3, 4 comma 3, 1 comma 2, 2 comma 3, like this, suppose. And to check whether they are the points on the square, we need to find out what is AB, what is BC distance, what is CD distance and DA. If they are all equal, then we can say that the points are the vertices of a triangle, vertices of a square. To check whether they are vertices of a parallelogram, opposite sides are equal, diagonals bisect. Vertices of a rhombus, adjacent sides are equal, diagonals are not equal. Vertices of a square, all the 4 sides are equal, diagonals are also equal. Like that, we can make use of this distance formula to find the properties of the plane figures. So far we used to consider, yes, opposite sides are equal, diagonals bisect, diagonals are equal, diagonals are perpendicular to each other. Now here we are going to prove theoretically, it's not only the statement, yes, they are equal, they are equidistant. This is another application of this distance formula. We can also make use of this distance formula to find out the types of the triangle. That is, how to identify the types of the triangle. If all the 3 sides are equal, it is an equilateral triangle. If 2 sides are equal, it is an isosceles triangle. If satisfy Pythagoras theorem, that is square on the hypotenuse equal to sum of the square, then we consider they are the sides of the right triangle or sides of the right isosceles triangle. If all the sides are unequal, we can find out they are the vertices of a scalene triangle. That also we can find out using this distance formula. And also we can find out the area of a rhombus using this distance formula, that is finding the distance from A to C and B to D, you will get D1 and D2. Area can be taken as half into D1 into D2. This is also one of the application of this distance formula. And also we can find out whether the points are collinear or not. Usually we used to find out these points are collinear by the application of area formula, but area formula has been deleted, so then we make use of betweenness property. Suppose if the points are A, B, C are given, to check they are the points or collinear. So then we have to find out AB, we have to find out BC, then AC. If AB plus BC is equal to AC, or instead of B, if the point is C, then we can say if AC plus BC is equal to AB. If it satisfies betweenness property of the line segment, then we can mention the points are collinear. Otherwise, the points are not collinear. So now, making use of this distance formula, let us have very simple questions which is not in the textbook. And one more thing I want to inform you. Now at present I am not at Mysore, so I am adjusting with this board, and in order to continue your class without any break, I am making myself with this convenient board. So don't miss the class. Okay, again and again I am informing, even in the yesterday's class also, many are very careless of answering the test in time, submitting the answers through PDF. So I decided those who are given up their assignments and in PDF form, for them only here onwards the assignments and the test paper will be sent. Okay, otherwise no use of putting the pressure. Here also at the end I will call the names, those who are present in the class, for them only separately, individually I will send the link. Let others be stay at home. Unless if there is a genuine reason, I won't allow them for the class. It's my what is the concept, what I decided. Because of your carelessness, I decided not to take the revision. I would like to continue my class. Okay? Yes, we'll have the question based on this. Since its space is very less, I just rub the coordinate geometry. We'll make use of this space only to get the maximum problems. And the questions which I have done here, you will get as an worksheet later. So don't take the questions, just listen the question and see the method, work out in your book, and later if you can go through the video and get the question. Otherwise, you will get the questions later. Okay? Yes. First question. Find the distance between the points. First question. Find the distance between the point AB where A is 2, -2, B is -2, 1. I will show you in the beginning how to consider the distance formula as its application. Distance AB. We have the formula root of x2 minus x1 whole square, y2 minus y1 whole square. So for the beginning, let us write what each represent. What is x1, 2, y1 minus 2, x2 minus 2, y2 it is 1. x1, y1, x2, y2. Let us apply to this. You have x2 minus x1 minus 2 minus 2 minus 2 minus 2 whole square. y2 minus y1. 1 minus of minus 2 whole square. What you will get? Root of minus 4 whole square is 16. 3 whole square is 9. Root of 25. The distance is 5 units. So don't consider always you will get the perfect square only, not necessary. You may get the number which is not a perfect square. Even that also we should consider. It is the distance between the 2 points of a given order pace. Is it clear? Please take down this. Shall I move on to the next question? Yes. Next question. Find the distance between the points 5 comma 2, 2 comma minus 2. In the beginning, try to write the formula for each question. Find the distance between the points 5 comma 2 and 2 comma minus 2. A 5 comma 2, B 2 comma minus 2. So before applying to the formula, let us write what is x1, what is y1, x2 and y2. Now apply the formula. Distance AB equals. Repeat the formula because you have still more other formulas to remember. It is x2 minus x1 whole square, y2 minus y1 whole square. It is root of x2 here is 2. 2 minus 5 whole square minus 2 whole square. Minus 2 formula minus. If there is negative with negative formula, you should multiply with the formula. Okay na? What you will get? Minus 3 whole square. Square of a negative number is positive. So 3 square is 9. Minus 2 is minus 4 square is 16. Again it is 25. Its answer is 5 units. So we have found out the distance between the 2 points by the application of distance formula. Next question. Take it down and write up the formula, putting the question number one after the other. Continue your answer. Next. If 0, 0, comma 0 and P 4, comma 5, find distance OP. That is, by seeing the order pair, we can guess that one of the point is at the origin. When one of the point is at the origin, we have the alternate usage of the distance formula, that is root of x square plus y square. That is root of 4 square plus 5 square equals root of 16 plus 25. It is root of 41 units. Instead of mentioning 0, 0, comma 0, you may get the question, find the distance between the point from the origin to the point. Then you have to consider when they mention origin, its order pair is 0, 0. Okay. So now I will move on to next to type usage of the same application of the distance formula, but the type is different. Shall I move? Yes. Next question. Find the value of k. Find the value of k if the point P. Find the value of k if the point P 0, 2 is equidistant from A 3, k and B k, 5. Equidistant. So when they mention equidistance, what is the condition we have to take? Since point P 0, 2 is equidistant. So what condition we can take? What is the condition? Yes, PA equals PB. So for separate, we have to apply the formula. That is in order to avoid the root, I will make this PA to PB as PA square equals PB square. So that the distance formula root we can take it off. You will get just x2 minus x1 whole square plus y2 minus y1 whole square equals x2 minus x1 whole square plus y2 minus y1 whole square. Is it clear? I took PA equals PB as PA square equals PB square. So the root in the distance formula we can remove, so that without root we can have the distance formula as x2 minus x1 whole square y2 minus y1 whole square. Let us take here, if you take PA x1 y1 x2 y2, right? PB x1 y1 x2 y2. So now x2 minus x1 means 3 minus 0 whole square k minus 2 whole square equals k minus 0 whole square 5 minus 2 whole square. I think it's clear for you all. x2 minus x1 y2 minus y1 x2 minus x1 y2 minus y1. If you are confused, you can write what is x1 y1 x2 y2 in the working column or somewhere in the beginning. Later you can substitute. What you will get? 3 square means 9. Here we have to substitute a square minus 2ab plus b square. Here a square. 5 minus 2 is 3. 3 square is 9. So plus 9 minus 9 cancel. K square get cancelled. What you will get? Minus 4k equals minus k square. 1k again cancel. Minus 4 equals minus k. Therefore, k equals 4. K equals 1. A square minus 2ab. Oh, instead of b square, I took it as k square only. Sorry. So what you will get? This k square get cancelled. Here 4k equals 4. So cancelling. Oh, sorry. Here you will get minus 4k equals minus 4. K equals 1. Clear? Condition, since the condition here, the points are equidistant. The question they are given, the points are equidistant, therefore PA equals PB. Suppose the point is on x-axis, you have different condition. Point on y-axis, you have different condition. Points are collinear, another condition. For all, the application is distance formula only. With respect to the given condition mentioned in the question, you have to move. Like AP here also you have wide varieties of questions. So but try to understand what is asking in the question. It's very, very important. Okay, na? Shall I move on to the next question? Is it audible to everybody? I'm not shouting. It's a small room. I am just talking like this. Is it clear? Is board is clear and my voice is audible? Any problem you are getting? Please, so that I can make change in the next class. No problem. Yes, please don't come to my place there. I am not at Mysore. Many of them given the this one, given the message that after the tuition I will come tomorrow. I will come this week. I will submit. No, yeah, I won't be available till next Monday. So you have to adjust with this and you have to cooperate with this. Okay, instead of missing the class, this is only the alternate method I am doing. Yes, please. Next question. Which point on y-axis? So point on y-axis means what we can take? Point on y-axis. Yes, 0, comma y. Question. Which point on y-axis is equidistant from A 5, comma minus 2 and B minus 3, comma 2. 5, comma minus 2 and minus 3, comma 2. It is given point 2 condition. One condition is point is on y-axis and point is equidistant from these 2 points. So now we have the condition, let P 0, comma y be a point on y-axis. PA equals PB. It is given. To remove the square, I just write which implies PA square equals PB square. Squaring LHS and RHS. Now let us apply distance formula. Here PA x1, y1, x2, y2. PB x1, y1, x2, y2. What you will get? I won't write the formula. You should write the formula. Yes, write the formula. Will wait. Then I will substitute. Yes, write in the LHS x2 minus x1 whole square plus y2 minus y1 whole square. RHS x2 minus x1 whole square y2 minus y1 whole square. Taken? So now let us substitute. X2 minus x1, 5 minus 0 whole square. Y2 minus y1, minus 2 minus y whole square. Note down, I have taken here minus 2 as it is. Suppose 2, then if you have the negative, you should multiply. And in BB, what you'll get? Minus 3 minus 0 whole square, 2 minus y whole square. Expanding from LHS and RHS, let us take 5 square is 25. Here please note down how I am going to expand. A square is 4, B square is y square, minus 2ab. Minus 2 into minus 2 into minus 2, you will get minus 4y. Is it clear? 2ab minus 2ab. What you will get? Minus 2 into 2 into 2, minus into minus plus, plus into minus, correct? 2 into b, minus 2ab, minus into minus plus, plus into minus minus. But here in the beginning, square of a negative number is positive, you will get plus. Here it is minus 3 square is 9. Then a square minus 2ab plus b square. Is it correct? Minus 2ab a square plus b square minus 2 into a into b. Now here we should not add this negative, it is plus only. So this is plus. Because while expanding we cannot take the negative here. Sign is already the expansion of a minus b whole square. Right. So what you will get? Y square get cancelled. Plus 4 get cancelled. 25 plus 4y equals 9 minus 4y. I will transfer here, it becomes 8y equals 9 minus 25. 8y equals, what is 25 minus 9? It is 60. Therefore, y equals minus 2. That means the point on the y-axis is 0, minus 2. At what point on the y-axis it lies? At 0, minus 2 it lies. Is it clear? Check it once. Here please note down a square plus b square minus 2ab. Minus of minus plus only you will get it. We are not considering negative in the formula. Only the first term is negative, it is negative. So after getting y is equal to minus 2, here you have to write which is that point which is equidistant on y-axis, that is P 0, minus 2. You can check this. How can we check? If you find the distance PA by putting y is equal to 2, PB, both will have the same distance. We can do the verification. Sometimes they will give up the question. Also verify your answer. Then putting y is equal to minus 2. If you check the distance, they are PA is equal to PB. Go through this. Is it clear to everybody? Since the question they have given, the point is on y-axis, we have taken this. Suppose the point is on x-axis, we take x minus x, 0. Point on y-axis, 0, y. Okay, na? Shall I move on to the next question? It's clear to everybody? Next, another hot question. The points A 3 comma 2, B 2 comma minus 3 are equidistant from the point P x comma y, are equidistant from the point P x comma y. Find a relation between x and y. Condition: this is point B with order pair 2 comma 3. This is point A with order 3 comma 2. Condition: these 2 points are equidistant from the point P x comma y. Here point is not either in x axis or y axis. It may be in any quadrant. Okay. In such cases, what could be the relation? What is the relation in terms of x and y? You have to calculate. So it is given, let p x comma y is equidistant. Therefore, PA equals PB, which implies PA square equals PB square. These things you have to write. Now write up below this condition the distance formula: x2 minus x1 whole square, y2 minus y1 whole square in LHS, same thing in RHS. Completed? Now PA x1 y1 x2 y2, x1 y1 x2 y2. For LHS and RHS we have to prove. Okay? So what you will get? PA square x minus 3 whole square y minus 2 whole square x minus 2 whole square y plus 3 whole square. You won't get any specific value. You will get an equation in terms of x and y. Later I will give out on that equation what we can find out using section formula. At the present, let us have the relation. Same type of question is given in the textbook also. So now expand it. A square minus 2ab plus b square. Is it clear? A square minus 2ab plus b square. Next, a square minus 2ab plus b square. We have y, here we have x. Similarly, a square minus 2ab plus b square, a square plus 2ab plus b square. Check it once. See the expansion in LHS and RHS. Now you can cancel x square, y square from both the side, and plus 4 and plus 4 from both the side. Anything? Plus 9 and plus 9 from both the side. What is left? Minus 6x minus 4y equals minus 4x plus 6y. So transferring minus 2x minus 10y equal to 0. Dividing it by minus 2, you will get x plus 5y equal to 0. This is the relation in terms of x and y. Check your answer. I will be waiting for your completion. x plus 5y equal to 0. Completed? Yes, is it clear to everybody? Next question. Find the coordinates of point on y-axis, x-axis. Point on x-axis is x comma 0. Find the coordinates of point on the x-axis which is equidistant from A 2 comma minus 5, B minus 2 comma 9. Try ಮಾಡಿ. Condition: point A and B are equidistant from the point P x comma 0 which is on x-axis. So write your answer with the starting statement. Let P x comma 0 is equidistant from A and B. Therefore, PA equals PB, which implies PA square equals PB square. Now apply distance formula. Get the value of x. Yes, substituting. Are you all trying? X minus 2 whole square, 0 plus 5 whole square. You can take from here to here or from there to here. You will get the same answer. In the beginning only I mentioned x plus 2 whole square, 0 minus 9 whole square. Now further expand x minus 2 whole square as a square minus 2ab plus b square plus 25. Now RHS, you expand a square plus 2ab plus b square and minus 9 square is plus 81. This you have to keep in mind. Don't write here minus 81. Now can we cancel x square here? Plus 4, but we cannot cancel this. When I transfer here, it becomes 8x equals 81 minus 25. Minus 8x equals minus 81 minus 25 is 56, correct? Therefore, x equals minus 7. When x equals minus 7, then we consider the point on x-axis is minus 7 comma 0. When it is on y-axis, we write it as 0 comma minus 7. Since the point is on x-axis, I think it is clear. All these points you have to keep in mind. When the point is on x-axis, minus 7 comma 0. When it is on y-axis, 0 comma minus 7. When they are equidistant with the point p x comma y, Then you will get an equation in terms of x and y. All the types I covered here, you can go with the textbook questions also. Whichever you comfortable to answer, try to answer it as a practice. Okay? Over? Yes. Another question. We have to find out the given points or the vertices of a rectangle. In a rectangle, we can show opposite sides are equal. Diagonals also equal. Diagonals bisect is also there. That we can prove later. Okay. Using another section formula with midpoint formula. Now to show that they are the vertices of a rectangle, if you are able to show opposite sides are equal, diagonals are also equal. Take the question. Prove that the given points are, prove that the given points are vertices of a rectangle ABCD with the order pair A 2 comma minus 1, B 5 comma minus 1, C 5 comma 6, D 2 comma 6. So to check first, let us find out the distance AB, CD. Then BC, DA. If opposite sides are equal, then again you have to prove whether the diagonals equal or not. Okay? AB distance using distance formula. For the beginning, I will write the formula. For other sides, directly we can make use of the given condition. Okay, na? That is x2 minus x1 whole square, y2 minus y1 whole square. What happened to Vagdevi? Is it clear to you? See the order pair of AB, x1, y1, x2, y2. That is y2 minus x2 minus x1 whole square, y2 minus y1 whole square. Minus of minus, it becomes plus. What you will get? Root of 5 minus 2 is 3 square. It is right. Root 9 plus 0, 3 units. Let us calculate its opposite side, CD. It is root of 5 minus 2 whole square, 6 minus 6 whole square. It is root of 9 plus 0, again 3 units. So one set of condition, that is opposite sides are equal. Again we see BC and CD. BC, it is root of BC, 5 minus 5 whole square minus 1 minus 6 whole square. It is root of 0 plus 49. It is 7 units because root 49 is 7. Now calculate AD. It is root of 2 minus 2 whole square minus 6 minus 1 minus 6 whole square. For everything I am using the distance formula x2 minus x1 whole square y2 minus y1 whole square. I hope it is clear. You will have root of 0 plus minus 7 square is 49. It is 7 units. So we proved opposite sides are equal. This itself is right. They are the sides of the rectangle. Even if you want further, you can prove the diagonals are also equal. Check it. Getting AC diagonal distance and BD diagonal, check whether they are equal or not. I'll give the time to check whether the diagonal AC is equal to diagonal BD. Are they equal? Yes. What distance you will get? What distance AC and BD measurement? Root 58 you will get it? Yes. Root 58 in both the cases. It's satisfying the properties of a rectangle. Opposite sides are equal and the diagonals are also equal. So now it's clear what are the application of distance formula with respect to the geometrical properties. What so far we used to consider, that is proved using Cartesian plane condition. When they are placed on the Cartesian plane, when we measure, they are equal in length. Without actually measuring, having the calculation by the usage of distance formula, also we can check they are the vertices of a rectangle. Is it clear to everybody? Yes, good. Next question. Again, one more verification whether they are the vertices of an isosceles right triangle. For isosceles right triangle, what will be the condition we have to prove? Come on. If it is an isosceles right triangle, but we cannot say that it is right angled at B only. So in the beginning, I won't write the right angle triangle. The points are A, B and C. If you show that any two sides equal and square of those two sides is equal to the sum of the squares of those two sides equal to square of the hypotenuse, then we consider they are the vertices of the right isosceles triangle. If you show these two sides are equal and sum of the squares of this is equal to this, then we can say the angle opposite to side will be the right triangle. Then I can locate. In the beginning, I cannot say whether it is right angle at A or B or C. Just I am giving the figure right isosceles. Isosceles means these two sides should be equal. This should be 90 degree, means should follow Pythagoras condition. So I'll give the values of A, where A is 0, 0, B is 5, 5, and C is minus 5, 5. Okay. Now let us calculate first, taking first two sides with the application of distance formula. Write up in the beginning for one time the distance formula. What is that? X2 minus x1 whole square, y2 minus y1 whole square. You will get root of 25 plus 25, it is root 50. Root 50 can be taken as in the simplest form as 5 root 2, or let us in the beginning we'll write it like this, units. This is one of the side. Next, after AB we take BC. It is root of minus 5 whole square, 5 minus 5 whole square, x2 minus x1, y2 minus y1. Minus 5 is minus 10. Minus 10 whole square is 100 plus 0, it is 10 units. Next, AB, BC, then AC. It is minus 5 minus 0 whole square, 5 minus 5 whole square. What you will get? Minus 5 minus 5, 0 whole square, 5 minus 0 whole square. You will get root of 25 plus 25, root of 50 units. So with this value only we can consider here AB equals AC equals root 50 units. So when AB equals AC, it is right angled at A. Then AB square plus AC square should be equal to BC square. What is AB? It is root 50 whole square. Root 50 whole square equals 10 units. That is 10 square. So 50 plus 50 equals 100. 100 equals 100. It is verified. That means they are the vertices of right isosceles triangle. In the beginning, we cannot guess which is right angle. After getting the values, we can show that here it is right angled at A, and AB and AC are two equal sides, and BC is its hypotenuse. Yes, it's clear to everybody. Okay, I'll go with one more last question, then I will conclude today's class. So now it is clear how we are going to use distance formula to check out the properties of the plane figures. So now here is another question where we are going to check out the given points or the vertices of a rhombus. In the rhombus, all the sides are equal, but diagonals are not equal. In a square, all the sides are equal, diagonals are also equal. Got the difference? Now let us check whether the given points 3, 0, 4, 5, minus 1, 4, minus 2, minus 1 are the vertices of a rhombus but not a square. How will you differentiate the vertices of a rhombus but not a square? Here, like square, rhombus also all the four sides equal. But if the diagonals are not equal, they are the vertices of a rhombus. If they're not a degree is not, now we cannot show using distance formula. We can show only it is not equal. If they are equal, then it is a square. If they are not equal, with all the four sides are equal, it is a rhombus. So we have to calculate the measure of all the four sides and also the diagonal. Calculate using distance formula, AB distance. It is 3 minus 4. Also we can take 4 minus 3 also, plus 0 minus 5 whole square. What you will get? 3 minus 4 means 1 square is 1, plus 25. It is root 26 units. Similarly, calculate BC. It is root of 4 plus 1 whole square, 5 minus 4 whole square. Check it again, you will get root 26 units, because root 4 plus 1 means 5 square is 25. BC. Then CD. It is minus 1 minus of minus 2. 4 plus 1 whole square. Again it is root 26 units. Find out AD. It is root of 3 plus 2 whole square, 0 plus 1 whole square. So we have shown that all the adjacent sides are equal. Now to discriminate from their square, if you show that the diagonals are not equal, your answer, yes, it is the rhombus vertices. So calculate the diagonal AC. You have to get the distance A to C, 3 plus 1 whole square, 0 minus 4 whole square. It is root of 16 plus 16, root 32 units. Then diagonal BD, root of 4 plus 2 whole square, 5 plus 1 whole square. It is root of 6 square is 36 plus 36, root of 72 units. So diagonals not equal, all the four sides are equal. Then come to the conclusion, yes, they are the vertices of a rhombus. Suppose if you have the continuation, also calculate the area. Then make use of the formula half into diagonal 1 into diagonal 2. For the next class, get ready with this answer, that is the area of the rhombus. Why it is not a square, it is clear to everybody, since the diagonals are not equal. It is a rhombus, all the four sides are equal and diagonals are not equal. Therefore, it is a rhombus. I just concluded this. Calculate the area, then use this formula half into root 72 into root 32. You will get half into 72 into 32. So you'll get the final answer. Okay, na? I'll conclude this. Tomorrow again you have the questions on this coordinate geometry. If it is clear, go through the problem which is in the exercise, usage of the distance formula, so that further you can get confirmation. Okay, na? Shall I proceed in the next class? Okay. Thank you. See you in the next class.